Welcome to One Chemistry. Always do your best. Now let us see about 50 basics in organic chemistry. These basics can help you to become a master in organic chemistry. Stay tuned for complete information. Before we start, let us understand the fact here. Chemistry basics are like tables in maths. So, you should memorize it before understand it. Yes, you heard it correct. You should memorize it before understand it. So, you should memorize these facts without any question. First basic is isomers. In chemistry, isomers are very much important. Here I given the common isomers. The first one everybody know, cis and trans. Cis means the bulky groups are nearby, trans mean opposite to each other. The second one will be vicinal and geminal. Vicinal means functional groups are in nearby carbon, geminal mean in adjacent carbon. The next one will be axial and equatorial. In cyclohexane, the functional group away from the plane is called axial, its along with the plane is called equatorial. Similarly, endo and exo in the bicyclic system. Endo means it's inside the ring, exo means it's outside the ring. Similarly, in bicyclic system, another one will be there, which is syn and anti. Syn means the particular group is near to the double bond. Anti means the particular group is away from the double bond. It is like cis and trans but little bit different due to the bicyclic compound. Then we see the isomers in carbohydrates, which is called anomers. Anomers mean the functional group position differ in the first carbon is called anomers. Similarly, in epimers, differ only in any one carbon is called epimers. Here you should know cis and trans, vicinal and geminal, axial and equatorial, endo and exo, syn and anti, anomer and epimer. Next one will be chiral compounds. Normally chiral compounds are categorized into 4 types. The first one is chiral center. Chiral center is very common. Chiral center means carbon attached with 4 different groups. The second one will be chiral axis. Chiral axis means the chirality arised from the particular axis in the compound. The chiral axis normally existed in allene, which is cumulated diene compound, and biphenyl, one ring and another ring are exactly opposite each other, and spirenes. So, allenes, biphenyl and spirenes have chiral axis. Next type will be chiral plane. Chiral plane will be one side of the compound cannot be reflected perfectly in the other side of the compound. So, chirality rises from the plane. Normally, the plane chirality come from Ansa compound. Ansa compound means the bridged system in the phenyl compounds. The next one will be transcyclooctane compounds. What happened really here is the both rings are twisted accordingly to create a plane. The next one will be paracyclopane. Paracyclopane, the rings will be opposite to each other, so it creates the chiral planarity. The last one will be normally in biological system, which is spiral chirality. What really happens is due to the spirality, it creates a chiral compound. The normal one will be DNA and RNA and biphenyl compound which are in the spiral nature. So, these are all the 4 types of chirality. Next basics will be R and S configuration. Chiral compounds are the compounds which are attached with 4 different functional groups. Normally it is classified into R and S. R means the clockwise direction of the groups, S means anti-clockwise direction of the groups. R and S configuration normally generate the optical activity here. These are all called stereoisomers or enantiomers. It is easy to memorize from 2 diseases, cancer and AIDS. Cancer start with C, which represent clockwise, end with R, which represent configuration. Similarly, AIDS start with A, which represent anti-clockwise, end with S, which is configuration. Next basic will be steric effect. Steric effect normally come from the bigger groups. It is like big groups are competing for space. So it can be come from the origin of bulkiness. It can be three types. One is angle strain. Angle strain means you are forcing a particular group to the particular angle. Nature of the groups avoid the formation. The perfect example will be cyclopropane. Here strain come from the tetrahedral angle. Normally tetrahedral angles are 109 degree, but cyclopropane should have 120 degree angle. Hence the strain created from bulkiness of both groups and bending of its angle. The next thing will be similar one, which is torsional strain, which is come from the conformation of compounds, which we will see later. So torsional strain come from the bulky groups present in the compound. Here is on the 2-chlorine. This is the top view of dichloroethane. 2-chlorine cannot be nearby. It always forced away. Bulkiness create the torsional strain. Next and common one will be steric strain. Steric strain come from that bulky groups present in the compound and the active center. Here 3-methyl group present in the carbon and functional group as alcohol present in that same carbon. What really happens is this bulky methyl group don't allow the reaction. So this is called steric strain. So steric effect can come from an angle or a particular plane, or it can be from the bulky groups. Next basic will be arrow move from the electron while writing the mechanism. The mechanistic arrow should start from the electron to the empty place. But people don't understand it. They normally draw as empty space to electron, which is very wrong. It is not possible. The real thing will be electron move from rich to poor, not poor to rich place. Next basic tip will be distribution of charge. Distribution of charge normally create the stability. The more distribution of charges, more will be the stability. The distribution can come from resonance or bigger atom. Resonance means you are exchanging the charges and distribute it. Bigger atom means it always hold the charge very elegantly. So the resonance and bigger atoms can distribute charge very well. Here I shown the resonance of the anion. The anion easily switch from one carbon to another carbon, so it creates distribution and stability. Similarly, the charged species I minus and F minus. I minus is very stable when compared to F minus because I minus is bigger. It can distribute the charge very well. So it applied to anything, cation, anion or radical. So the charges or radical stabilized by the distribution. Next tip will be stability of functional groups. Normally carbon holding single functional group is stable. More than one functional group will be unstable. Here I shown the example. Carbon attached with 4 hydrogen is stable. Carbon attached with 1 chlorine also stable. But if you go for 2 functional group, chlorine and amine, the chlorine will be a leaving group. You will get the amine as a product. Similarly, amine and alcohol are both alcohol. So you should understand the fact that carbon normally stable with single functional group, not more than one functional group. Next basic is charge separation rule. Charge separation you should master it because charge separation drives a reaction. Normally charge come from that electronegativity. Most electronegative atoms should hold the negative charge, least electronegative one hold the positive. So you should not write reverse. So you should master that most electronegative atoms should hold the negative charge. If it hold the positive charge, it is very much unstable. Next basic will be stereoselective reaction. Stereoselective means the product has two possibilities but one will be dominates. Here we show the example, which is a bicyclo compound. Here the reaction epoxidation of bicycloalkene. Here the two possibilities. Oxidation can be above or below, but the above have steric effect of that bridged carbon. So only below is that possible thing. Since there is a two possibility, only one will be selective. This is called stereoselective reaction because the one product is very selective. Both are formed but only one dominates. The next basic will be similar one, which is stereospecific. Stereospecific is all about reactant, how the reactant allow the attacking molecule. The perfect example will be the simple one, which is SN2 reaction. SN2 reaction, which is always allow the backside attack of the attacking nucleophile. Hence, always inversion in configuration happening. Since you start from one, end with another one. It is specific, always attack is from backside, you get the inverse product. This is called stereospecific reaction. Next basic will be chemoselective reaction. The concept of chemoselectivity comes from multifunctional group compounds. Here I shown the biggest compound where there are many functional groups, which is carbonyl, ester, amine, alkane and benzene. So if reaction happen, where it will be happen? Some reactants selectively do the reaction on particular functional group. Here the BH3 only attack on carbonyl carbon. So here you get the alcohol only on carbonyl group, not on ester, not on amine, not on benzene. So the reaction is very selective based on functional group, which is called chemoselectivity. Next basic will be regioselectivity. What is regioselectivity mean? The reaction have the possibility of two attacking site, but the attacking species chooses the specific region. Here I shown the attack of HBr in the alkene. Here there are two possibilities. Bromine can attack the more substituted carbon or less substituted carbon, but bromine prefer the more substituted carbon. This is called Markovnikov rule, we will see later. The another possibility will be minor. This is due to the stability of carbocation. Regioselective means simply to understand that the bromine only attack on the more substituted carbon. Next basic will be stability based on the charges. Normally the charge should be 0 or lesser charge should be stable. Here first we see the example, which is carbocation, which is 3 plus, 2 plus and 1 plus. The high charge thermodynamically not possible, that's why it's unstable. So CH3 plus we normally see, we never see CH2 plus or CH3 plus. So the lesser the charge will be stable. The next one will be the stability based on the reduced charges or lesser charges. Here the carbon ion, suppose you are using the chlorine as a substitution, 1 chlorine substituted, 2 chlorine substituted or 3 chlorine substituted. What chlorine really doing is electron withdrawing group, right? So chlorine withdraw the electron. So the more the chlorine, more the withdrawal of electron, so lesser the charges. So the less charge will be always stable. Next basic on solubility. Solubility normally defined as like dissolve like. What is really meaning is polar compound soluble in polar solvent, non-polar compound soluble in non-polar solvents. If you mix it, it never was. Here we will see by example. We take the compound methanol and water as a solvent. Methanol is polar, we very well know that. Oxygen is more alternative than hydrogen. So it will pull the electron, so it gained a partial negative charge. Hydrogen will be partially positive. Similarly in water, oxygen possesses delta minus, hydrogen possesses delta plus. So both are polar, definitely methanol soluble in water. Next, the same methanol will not be soluble in hexane. Why? Because hexane there is no polarity. There is no positive and negative charge separation. So it is not soluble. So like dissolve like, polar compound dissolve in polar solvents. Next basic is on functional group. Functional group you should memorize, you should know. Why? Because functional group only participate in the reaction. So you should be master in the functional group name. So when you see the any compound, you should look for the functional group. The functional group normally will be halides or hydroxy group or carbonyl groups or alkene or alkyne. So look for a functional group in big molecule. Next tip will be you should know the charge in the functional group. Why it is important? because it will dictate the reaction. So the charge easy to memorize because it based on the electronegativity. Here I given the electronegativity of basic atom, which is boron, carbon, nitrogen, oxygen and fluorine are halides. Here the atoms after the carbon is more electronegative. So obviously it will gain negative charge, the carbon gain positive charge. Here is only example. Fluoride gain the negative charge, carbon gains positive. Similarly in alcohol, oxygen gain negative, carbon is positive. Carbonyl group also same, oxygen gain negative, carbon gain positive. Cyanide also same, so on and so forth. So you should know the charge in the functional groups. Next basic is conformation. What is really conformation mean? The single bonded hydrocarbons always rotate and stable on particular one. It is like rotating a chalk piece. What is really catch here? You should know how these atoms are organized. It is based on the bulkiness of the groups present in that one. Normally it is written as from the top view of the compound. You will see the molecule from the top means one carbon behind another carbon. Here is on the dichlorobutane. One chlorine exactly behind the another chlorine means it's called eclipsed or fully eclipsed means same atom backside. Similarly, the different atoms can be behind each other, which is called partially eclipsed. If the groups are 60-degree angle, it is called gauge forms, means the groups are nearby. The most stable and common one will be antiform, means the groups are far away from each other, which is 180-degree. So this is called conformation. Normally this will be observed in the lower temperature. The obviously stability based on the steric effect or repulsion. The most stable will be staggered, next gauge, then partially eclipsed and fully eclipsed. Next basic will be isotopic effect. What is isotopic effect? Isotopic effect, we are substituting deuterium for hydrogen. The deuterium bond strength is high, so it's difficult to break. There will be two types of isotopic effect, which is primary and secondary. Normally the isotopic effect will be the ratio of normal reaction versus deuterated reaction. For primary, the ratio will be greater than 1, secondary will be lesser than 1. It can be easily identifiable. If H plus is breaking, isotopic effect will be greater than 1. If the coordination is increasing or new atom attached in the same carbon mean it will be secondary, which is lesser than 1. So isotopic effect will be greater than 1 means primary, lesser than 1 means secondary. Next tip will be on popular intermediates. Popular intermediates are important. You should know that the intermediates are cation, which is positive charge, and anion, which is negative charge, and one electron alone species, which is called radical, and benzene, which is triple bonded in the benzene ring, then carbene, it's a pair of electron and carbene, and nitrene, which is also like nitrogen analog of carbene. These are the common intermediates formed in the reaction. You should master it. Next tip will be on leaving group. What is leaving group really meaning is the leaving molecule from the reactants. Here ABC is a reactant, leaving group will be C. The leaving group is important while determining the mechanism. You should understand it. The leaving group concept is important in substitution reaction because one group leaves and one group comes. So you should know the leaving group. Normally self-stabilizing groups or weak bases are good leaving groups. Self-stabilizing groups are tosylate and mesylates. Weak bases are Br- and H2O. The other things will be chlorine minus and CH3COO-. Poor one will be the strong bases, which is OH minus, OR minus and fluorine minus. It is easy to memorize. Self-stabilizing groups are better leaving group, then halogen, then oxygen, then nitrogen containing groups, and at last hydrogen will be the poor leaving group. Next, you should watch the leaving group. Next basic will be you should watch the leaving group. What is really mean that whether the leaving group taking out the electron or leaving the electron there. Taking the electron means it will form as cation. Leaving the electron means it forms as anion. Normally halogens leave with electron created cations. Similarly, the organometallic compounds leave as a cation, so left as anion. So, same carbon can be a cation and anion, leaving group normally deciding it. Next basic is how the reaction proceeds. Whether the reaction driven by the charges or without charges. Here I shown the reaction, which is bromobutane and OH minus reaction. Here merely exchange of two negative group, which is Br minus replaced by OH minus. This kind of replacement of ion is called heterogeny, normally determined by Coulombic interactions. Next thing will be on radicals. Radicals having the single electron. So normally due to its poor stability, quickly it forms a reaction. So the reaction can be charged or not charged. So you should memorize the charge on the functional group. So you can easily understand which one will leave which one. Next important one is electrophile. Electrophile is normally the electron deficient system or positive system. Normally it classified into four types. First one is easy one, which is positively charged one. Any cation can be the electrophile. Second one will be the incomplete octet, meaning it has space as well as it don't have the stability. So it accepts the electrons there. So BH3 will be good electrophile. The next and a very rare one is empty d orbital in the compounds, which allows the expansion of octet and accommodate the incoming group. So it can also act as electrophile. The next one will be on the main group attached with highly electronegative atom. Here I shown PCl5. Chlorine is very much electronegative and it creates the very high partial positive charge on phosphorus. So it can also act as electrophile. So the common electrophiles can be on positively charged or incomplete target or empty d orbital or pull down electrons. Common electrophiles are given here: CH3 plus and X plus and CO2, BH3, BCl3, so on and so forth. The next basic is on nucleophile. The nucleophile is opposite of electrophile, which is electron rich and negatively charged. It will love the positive charge. The common one will be a negative charges, which is anion, or the compound with lone pair of electron, which is like ammonia, which have one lone pair of electron, which can attack the positive species, or electron rich multi-bonded compound, which is triple bond and double bond. The common nucleophiles are OH minus and NH2 minus and Cn minus and R minus. There will be many, but you should memorize this one. Next and very important basic is stability of carbon ion. How the carbon ion is stabilized? Normally the primary carbon ion is more stable and secondary and tertiary will be the least one. Why it is so mean? It is due to the inductive effect of methyl group. Methyl group is a plus I effect group, so it increases the charges on the center. So more methyl group, lesser the stability. You should memorize it. So anion primary carbon is stable. You should memorize as A primary, which is first letter. So A is stable, easy to memorize. Next tip will be stability of cation. The cation center will be positive charge, so same electron donating methyl group will stabilize it. So tertiary will be more stable, secondary will be the next one, primary will be the least one. It will be also easy to memorize. Cation tertiary carbon is stable. So cation letter is C, which is tertiary. So C is the third letter. So cation tertiary is stable. The important note here is the radical stability also equally like cation. Next and very important basic is cation generation. You should know when and where the cation is generated. The normal one will be CH3Cl. If the catalyst is aluminum chloride, you can generate the methyl cation. Similarly, in acid chloride, you can generate the cation by Lewis acid, which is CH3CO+. cation also generated from the reaction, which is from alkene, you add H plus, you generate the cation. Similarly, the cation also formed by removing of water in alcohol. So alcohol, you add acid and you get the methyl cation. So you should know when the cation is forming. The next tip will be how the anion is forming. Anion formation in organic chemistry is rare. Normally anion comes from the organometallic compounds, more generally Grignard reagents. So the metals are more electropositive, which can easily generate the anion. So anion formed from CH3MgX or methyl lithium or dimethyl copper. Next tip will be on inductive groups. The inductive groups can be positive and negative. The positive inductive group means it withdraws the electron and polarizes the bond. Normally it happens when the carbon is attached with more electronegative atom. The more electronegative atoms are the atoms after the carbon in the periodic table. Here is shown the fluorine, which is attached to the carbon, which pulls the electron towards it. So it generates the positive charge on carbon, fluorine gains little negative charge. Here I given the minus inductive groups, which is nitrogen and halogen group, which is NH2, NO2 and Cn. Halogens, fluorine, chlorine and bromine and iodine. Oxygen groups are mostly carbonyl compounds or alcohols or OR minus or OAR minus. So the minus inductive groups are mostly electronegative groups, mostly higher electronegative atoms. Then the plus inductive group. Plus inductive groups mostly on methyl one or electron rich species. Methyl is a very good electron donor based on the hyperconjugation or merely positive inductive effect. So electron donating groups which polarize the bond and donate the electron. So common ones are methyl or substituted methyl or electron rich species CO minus and O minus. So you should know this fact that inductive effect can stabilize or destabilize the intermediates. So plus inductive effect stabilize the positive charge, minus inductive effect stabilize the negative charge. Opposite of this will be the destabilizing factor. It will be easy to remember: plus stabilize the plus, minus stabilize the minus. Next basic is very important one, which is resonance. Resonance is like you are holding the hot water, you are exchanging your hands to reduce the heat. Similarly, charges are like hot one, which is very much unstable. If you exchange towards carbon, it will be very stable. It can be applied to anion and cation or can be the radical. The important thing will be the more resonance create more stability. So resonance is a stabilizing factor in the compound. Next basic is on imagining hydrocarbon. You should imagine hydrocarbons very well. There will be many notations are there. Here I given the common to complicated one. Here I given a ethane. Normally written as CH3 and CH3. But how it really look at the 3D animation where the bond is rotating, where CH3 group on front, another CH3 group on back side. The same thing can be written as Fischer formula, which is representing as hydrogen above and hydrogen below, or simply write as cross sign. Then the Newman structure. Newman structure is you are seeing the molecule from top where both tetrahedral structures are behind each other. Next thing will be on Saar structure. It will be like writing only skeleton and look the molecule. The next thing will be like wedge or like Fischer type structure, which you are writing 3D molecule in 2D paper. So the molecule below the plane you written as dotted wedge. The molecule above the plane you written as solid wedge. So the same thing can be written as many forms. So imagine better for master the organic chemistry. Let us get into little bit advanced thing. The basics of mechanism. The mechanism is normally the step-by-step process in the reaction. It can be of many things. Normally the reaction represented as reactant to product, but it can be catalyzed It can be forced by temperature and pressure or light. The solvent assists the reaction to proceed. So, the reactant to product can be on many factors. Where is the electrophile comes, nucleophile comes, substrate effect, rate, specificity, product. The product can be thermodynamic or kinetic, or intermediate is forming or not. So there are many factors all you should consider before writing the mechanism. So you should remember all these facts to write the complete mechanism. Next, basics on how you write the mechanism there. Mechanism normally categorized into with charge and without charge. With charge is very common, which is fully charged, which is anion and cation, or partially charged. Partially charged means by inductive effect. Fully charged means it can be nucleophile and electrophile. Without charge is very rare and advanced, which is pericyclic reaction or cyclic reaction or radical reaction. The single electron transfer is a very advanced one, but it is also possible. So while writing mechanism, you should know whether it is follow with charge or without charge category. Next and very basic one is arrows. You should know the arrows in the organic chemistry. The simple arrow represents the irreversible reaction, which is very common in organic chemistry. The double side arrow shows the reversible reaction, meaning the reactant can be converted into product. The reaction with cross symbol is called no reaction, meaning it is not possible at all. The double-headed arrow represents the resonance, which is very common. And sometimes the forward reaction dominates the backward reaction. You should know this kind of notation. And very common in conversion chemistry, which is double arrow, which is one arrow next to the same arrow, which is represent the multi-step reaction. So you should memorize the arrow structure here. Then you should know the arrow types. Arrow can be full-headed arrow or partially headed arrow. The partially headed arrow represents one electron is moving. Normally it's homolysis where the radical formation is occur. The full-headed arrow represents the complete electron transfer, normally the cation and anion formation or nucleophile and electrophile formation. So the full arrow represents ion formation, the partial arrow represents radical formation. Next tip will be on common reaction types in organic chemistry. These are the common one, you may know it already, but you should know that. Hydrolysis means you are adding the water inside the reaction. So addition of water is called hydrolysis. Next thing will be on oxidation. Oxidation means you are adding oxygen to the system. So in the normal example will be aldehyde to acid where one oxygen is more. The reduction means the addition of hydrogen. The addition of hydrogen means you are adding the reducing agent, supply the hydrogen and the hydrogens are straight away adding there. Isomerization means switching of atom inside the molecule without changing the molecular formula. Normally it is a different arrangement of the atoms. So hydrolysis, oxidation and reduction and isomerization you should know. Next basic is on electronic effects. You should know that normally the organic chemistry all about electron transfer. So you should know these two effects. One is polarization effect and polarizability effect. Polarization is the permanent one. Polarizability is the temporary one. Let us see the permanent ones. Permanent one, first one will be the inductive one. We already see. The electron can be pushed or pulled from an atom. Mesomeric means the electron can be switched inside the molecule. It is called resonance. Hyperconjugation means the hydrogen donate the pair of electron and stay outside the system, which is also called no bond resonance. The next and rare one will be field effect. Field effect means the molecules create the interaction through space. So here you see the bulky chlorines are repelled by the carboxylic acids. So the interaction through space is called field effect. The temporary one will be the induced one, which is inductometric effect and electromeric effect. Inductometric effect means you are adding the charged species to the system which weaken the bond there. So you are introducing charge to the neutral system. The electromeric effect means you are directly adding to the system. So you are adding in the one, you are inducing in the one. Inducing is called inductometric, adding is called electrometric. Next basic is on solvents. Solvents can be two types, polar and non-polar. Polar technically defined as dipole moment should not be zero. Non-polar means dipole moment equal to zero. Mostly the symmetrical molecule dipole moment is zero. Normally carbon disulfide, which is linear one, or carbon tetrachloride, or cyclohexane or hexane. These are all the non-polar solvents. The polar solvents can be protic or non-protic. Protic means the solvents with hydrogen. Non-protic means solvents without the hydrogen donor there. The protic is easy to remember, which is fluorine and oxygen and nitrogen with hydrogen, which is water, methanol, or amine or hydrofluoride. Non-protic means normally this hydrogen don't participate in the reaction, which is non-polar hydrogen is inside. Normally acetone, ether or dioether or the cyclic ether. So solvents you should know whether it's polar or non-polar, protic or non-protic. Next basic is on types of reaction. The normal ones are addition and elimination. Addition means you are adding one atom to the system. Here A and B a molecule, you are adding a C. The reversible reaction will be called elimination. So ABC you are eliminating only one atom is there, it is called elimination. And then substitution. The substitution means in the same AB you are replacing B with C. So the replacement of B and C is called substitution. The addition and elimination and substitution is very common one. Next thing will be is decomposition. What is really decomposition mean? You are breaking the molecule into pieces or exploding the molecule into pieces. It is different from elimination. Elimination you are eliminating only one atom or molecule. Here decomposition means you are breaking into pieces. The cyclization means you are forming a cyclic structure from the reactants. Rearrangement means you are exchanging atoms in between that one. Here breaking of bonds between the atoms are happen. It is different from isomerization. So you should know these different types of reaction in the organic chemistry. Next tip will be on steric effect. Steric effect is normally a crowding effect and reaction center. It decreases the possibility of the reaction. Let us see the normal and steric case. The normal case, the OH is attacking the methyl chloride there. The product will be easy. Chlorine will be substituted by OH. Let us see the steric case. Same methyl substituted by 3 methyl groups where OH cannot attack there. So there is no reaction there. Hence the reaction is possible. So crowding of molecule by the substituent is called steric effect. Next basic is on ortho and para directors. In the substituted benzene where the next group will come is the mystery there. Where it will come in ortho or meta or para or second or third or fourth position in benzene. So it will be easy to memorize and remember. Minus inductive groups direct to meta, plus inductive groups direct to ortho and para. It will be easy to remember POP MOM. POP means plus inductive groups ortho and para, minus inductive groups direct to meta. So ortho para direct group you should know that. Next tip is on acidity. Acidity in organic compounds come from H+. It's normally the acid group which is COH or can be phenol or can be alcohol. Normally the alcohol is the least one. Carboxylic acid is the stronger one. The H+ donation ability of carboxylic acid come from its resonance. The next also acidity can be defined by hybridization. Hybridization means the more sp character more will be the acidity. Or acetylene will be more acidic than methane. So triple bond has higher acidity than single bond. So more S character, more acidity. The important facts you should know that is minus groups increase the acidity or lower the pKa or lower the pH. So you should memorize it. Next tip will be on basicity, which is opposite to acidity. The organic compound basicity comes normally from lone pair, which is Lewis basicity, mostly from nitrogen containing compounds. Normally the aliphatic compounds are more acidic than aromatic because of the hybridized compounds nature. sp3 carbon amines are more acidic than sp2 carbons because of the electronegativity or more S characters. The most important thing you should know is minus I groups increase the basicity or higher the pKa or higher the pH. So minus I groups donate the electron, increase the basicity. Next basic is SN1 reaction, which is normally the common substitution reaction. SN1 reaction normally occur with racemation reaction with tertiary carbons. The SN1 represents the unimolecular nucleophilic substitution reaction where nucleophile OH- attacks on carbocation. Here only one species decide the reaction, that's why it's SN1. So the tertiary butyl chloride converted into tertiary butyl alcohol by SN1 reaction, which is easy to memorize. Short mean SN1, racemation and tertiary carbon. Next basic is an SN2 reaction, which is opposite to SN1 reaction where two species participate in the rate determining step. Here the methyl chloride attacked by OH- which form the two species transition state form methyl alcohol. Here two species decide the reaction, hence the order is 2. So SN2 reaction normally comes with inversion because of the backside attack normally occurs in the primary carbon, which is easy to memorize as tip. Tip means SN2, inversion and primary carbon. Next basic is hydrogen bonding. Hydrogen bonding normally occur with fluorine, oxygen and nitrogen. The hydrogen bonding normally occur due to the electronegativity of those groups which attract the hydrogen and forms a very weak type of the bond, but is very important in biomolecules, so you should know that. The easy to remember is Hitler is speaking to phone, mean hydrogen bonding occur in fluorine, oxygen and nitrogen. Next tip will be on Sazop and Hofmann rule. Sazop and Hofmann rule is basically elimination. Suppose you are eliminating the HI group. Iodine is understandable you are eliminating, but for hydrogen there are two possibilities. Which hydrogen you will take away? That is called Sazop and Hofmann rule. Sazop means more substituted alkene will form. Hofmann means less substituted alkene will forms. So it will be easy to remember. Say more, cough less. Say means Sazop, cough means Hofmann reaction. Last but not least, Markovnikov rule. Markovnikov rule is all about selectivity. Suppose you are attacking chlorine nucleophile with alkene, where the chlorine will attack because both carbons are different, which is dictated by Markovnikov rule. Markovnikov rule says that most substituted carbon negative group will add. This rule will be easy to memorize. No members shall cheat. First letter will be easy. N means negative, M means most, S means substituted, C means cheat. So negative ion added to more substituted carbons. That's all from me today. I hope it will enhance your understanding. Thanks for watching. If you have any suggestion, comment below.